Hello and welcome to this video about spatial ability. We'll start this video by learning what are faces, edges and vertices. The flat plane as shown is called as a face. The place where two planes meet is called as an edge. The place where three or more edges meet is called as a vertex. The number of surfaces in a cube are 6. The number of edges are 12 and the number of vertices are 8. A cylinder has 2 edges and 3 surfaces, with no vertices. Note that the surface shown is counted as 1 since it is continuous all around the cylinder. Same can be said for the edges. So basically, any surface or edge which is circular or continuous will be counted as 1. This is a table showing the number of faces, edges and vertices of some basic forms. So now let's see what are plan and elevation views. For this demonstration, we will use a cube. When the top surface is viewed directly from above it, it is called as a plan. Viewing the front surface from directly in front of it is called as the front elevation. Same can be said for viewing the side surfaces, which is called as side elevation. For a cube's plan, viewing it from the top would mean that we are looking at a square shape. Note that the surfaces which are perpendicular to this top surface are not seen. Same observations can be noted for the front and side elevations. F stands for the surface considered as front and S for the side surface. A cylinder's plan results in a circle. The front and side elevations are rectangles. One way we can understand this is by considering the cross section of the cylinder, which is also a rectangle. Now we will see some other basic forms. When it comes to compositions, you can make plans and elevations in the order of the stacking of the forms. As you can see, the pyramid is stacked on the cube. So first, you can draw a square representing the plan of the cube and then stack the pyramid's plan on top of this square. You can follow the same procedure for plan and elevation views of compositions involving any number of stacking of forms. So now, the next few compositions will be displayed on the screen as a question. You can pause and draw the plan and elevation views yourself and then play the video again for the answer. For the next 3 questions, along with plan and elevation views, also count the number of faces, edges and vertices. Start by counting the visible faces, edges and vertices, followed by the ones which are hidden in the 3D view. Sometimes in plan and elevation views, certain edges as shown in the 3D figure by the magenta colored line remain hidden. The way to represent them is dotted lines, as you can see in the front elevation view. However, when the options given do not have any dotted lines, you can ignore the concept of hidden edges. In this kind of question, where you have to fold the net of a cube, look at the pattern of the 3 visible surfaces of the cube in the question. Then we can use the elimination method as follows. The vertex of the triangle meets the stripe pattern as seen in the cube. So option A, C and D are eliminated as the vertex is pointing in a different direction. This leaves us with the answer as option B. Pause the video and using the same method find out the answer. In this case, you will have to look at the relative direction of letters to one another. F and N are facing in the same direction in the question, which is also the net. So option A and E are eliminated. Letters S, O and N are in one line in the net, so it cannot appear on three adjacent surfaces of a cube. So option D is eliminated. Letter H and N are not in the same direction in the net, so option B is eliminated. This leaves us with the answer as option C. Pause the video and using the same method find out the answer. Remember that whenever a folding action is performed, it can be compared to horizontal or vertical flipping, with the flipping axis lying along the fold line. So in this case, it is flipping about the horizontal axis. This would mean the answer is option B. In these kind of questions, you have to take note of the proportions of the rectangles formed within the paper due to the fold lines. Observe the ratio of one rectangle side to its adjacent rectangle. Here, in all the options, the base is the largest rectangle. So now you have a starting point when you are folding the paper given in the question. Keeping in consideration the proportions of the rectangles in the question and comparing it to the options, the answer is option C. Alright, that's it for this video. See you in the next one.